Alright, in this video we're going to be talking about quadratic functions and transformations. Alright, particularly transformations. Alright, so students will be able to recognize changes to a parent function when given the function's equation. Alright, so the parent graph of a quadratic equation. Alright, so let's go ahead and plug 0 in, so 0 squared is 0. Put negative 1 in square is positive 1. Put 1 in square is positive 1. Negative 2 square is positive 4. And positive 4. So, parent graph, the vertex is at the origin. Got negative 1, 1. 1, 1. You got negative 2, 1, 2, 3, 4. And positive 2, 1, 2, 3, 4. Right, so that is what the parent function looks like. Okay. Now the domain deals with the x values, okay, which for here will be all real numbers. The reason why I say that, if it deals with the x values, look at the x-axis. You notice here as this keeps going up higher and higher, you see how this keeps getting wider and wider and wider? Well, it covers all the x values. So as this goes up higher and higher, it's going to get wider, so therefore it covers all the x values. So we say all real numbers. The range deals with the y values, or in other words, look at the y-axis. Here's the y-axis. You notice the graph comes down to here and goes right back up. So it doesn't go past the x-axis. Alright, so it touches, so the lowest y value, which is 0, alright, so how we say that is y is greater than or equal to 0. Because it's always going to be greater than that, right, because it's going up. Okay, so that's what the parent graph looks like. The vertex is at the origin, and the points are above the x-axis. Now, what happens to the transformation of a quadratic function? If you look at the parent graph, so here's the parent graph again. Here are the values, right? So we want to know what happens if a is negative. All right, so we're looking at a now. So we plug 0 in, 0 still gives 0. I plug negative 1, negative 1 squared is positive 1, but now it's negative. Now remember on that first video, see this is not inside parentheses, there's no parentheses, so therefore all of my answers are going to be negative. So it'll be negative 1, 2 squared is 4, but it's going to be negative 4 and negative 4. Right, so now we're going to graph this. So the vertex is still the same at the origin, but this time we're going negative 1, now it goes down. Instead of going up, it's going down. 1, negative 1, you go negative 2, negative 4, positive 2, and then negative 4. In other words, it's opening down. So the domain, again, is still all real numbers for the x values. The range, instead of, is now y is less than or equal to 0. So the range over here, when a was positive, was y is greater than or equal to 0. But since a is negative, now it changes. So it opens down. So it's a reflection across the x-axis. In other words, if I fold my paper on the x-axis, this part of the graph will fold right on top of this. This will fall right on top of this. Let's look at another aspect of what a does. Alright? So they say if the absolute value of a is greater than 1, in other words, you're looking at the value, looking at the number. We don't care about the negative or positive anymore, because the negative, we know what happens. We want to look at the actual number. Then we have a vertical stretch. Right? So if a is greater than 1, like 1.5, 2, 3, whatever. Right? So here, they made a 3. Now, if you also notice, it's positive, so I know it's going to open up still. Right? So A is 3. So now what we're going to do is, here's the parent graph. We're going to see what happens in relation to the parent graph. So I plug 0 for x, 0. 0 times 3 is 0. Negative 1 squared is positive 1 times 3 is 3. So I get 3. Negative 2 squared is 4. 4 times 3 is 12. And I get 12 again. You notice all my values should be positive because the square, there's no negative out front. So 0, 0, so the vertex stays the same. Negative 1, it go up 3, so it'll be 1, 2, 3. So what used to be negative 1, 1, now it's going negative 1 to 3, so my point is moving up higher. So positive 1, positive 3. Negative 2, positive 12. And then at positive 2, positive 12. All right. So we look here, we have a vertical stretch. In other words, the thing got skinny. I would say skinny. All right. Instead of getting wider, it actually got narrow or skinny. Okay. So that's what happens when A is greater than 1. We have a dilation. In other words, my graph gets skinny, or I have a vertical stretch. Now my domain is still the same. All real numbers. Right. It does get wider as we keep going up. It still keeps getting wider, but it still covers all the x-axis. It doesn't cover as fast as the parent graph, but eventually it does cover all the x values. Range, it stays the same because it still opens up, so y is still greater than or equal to 0. All right, so the last part of the transformations for A, all right, is the dilation. What happens if A is less than 1? All right, so we're going to look at it if it's at 1/3. All right, so that's less than 1. You notice A is still positive, so it's still going to go open up. Now, if this was a negative 1/3, it will open down. All right, but it's positive, so it still opens up. So we're going to plug these values in. I still get 0, but negative 1, I get positive 1/3. All right, so all my values are going to be positive. Positive 1/3. I get 4. Now, 4 times 1/3 is 4/3. Or 1.3 repeating, and same thing for this one, 1.3 repeating. So 0, 0, the origin or the vertex stays the same. This time I'm going negative 1, but I don't go up very far. And positive 1, same thing here. Negative 2, I just go a little bit past 1. And positive 2, just a little bit past 1. That's the reason I put these in decimals. That way I can approximate a little bit better. All right. If you notice, since A is less than 1, look how it got wider. You know, we call it vertical compression. All right. In other words, we're pressing down. We're pressing down on it. So as we press down on it, it gets flatter. So I like to say wider. All right. So, and then the domain is still the same. All real numbers. And the range is still the same. Y is still greater than or equal to 0. All right. So review. We have A, x minus h plus k. We looked at A. There's 3 things that A does. It's a reflection. In other words, is it positive or negative? If it's negative, it's a reflection. If A is greater than 1, absolute value, and we have the graph gets skinny. If A, absolute value of A is less than 1, it gets wider. All right? So A affects the graph in these 3 ways.